Let's start with today's topic. Um, and the first thing we want to do is graph y is greater than 4x minus 3. My y-intercept is negative 3. My slope is 4, or if you think about it, 4 over 1. This is my change in y, my change in x. So that means that up and down, going up and down, the movement should be up. Going left, let me just make that right, because it's positive. And then on the x, because the 1 is positive, it means go right. So you go 4 up, 1 right. Or 1 right and 4 up, it doesn't matter. 4 what? So 1, 2, 3, 4, 1 right. 1, 2, 3, 4, 1 right. And then my line is going to be dashed because it's just a grade, doesn't have an equal, so it has to be a dashed line. So dashed line. Now I do my test. So y equals 4x minus 3. I use 0, 0 as my test. So either we're going to go this way or this way. So 0 greater than 4 times 0 minus 3. 0 greater than 4 times 0 is just 0, and 0 minus 3 is negative 3. 0 greater than negative 3? Yes, it is. So this point 0, 0 worked, which means every single point on this side also is going to work, and we can use arrows like this, right, to indicate that everything on this side of that line will make that inequality true. Let me change colors. Change colors, you get y, y, hello, okay, y greater or equal to negative 2x plus 3. It's a negative slope, so it's going to be something coming down like that, right? So positive 3, 1, 2, 3, this is my y-intercept. Negative 2, right, it's my slope, so my slope is negative 2 over 1, right? So it means 2 down, 1 to the right, 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 2 down, 1 to the right. So this is a solid line. Okay, and label the line negative 2x plus 3, and I forgot to label the other line, y is greater than 4x minus 3. Now we got to do our test, so take this, use 0, 0, 0, 0 is from this side, so we're focused on the blue line, so 0 greater than negative 2 times 0 plus 3, 0 is greater than 3. Is that true? Obviously 0 is not greater than 3, so this test point 0, 0 did not work, and 0, 0 is to the left of the blue line, so we want to go that way, right? So points that are going to make the blue, the second inequality true, are to the right of that blue line, but we want points that satisfy both inequalities. So the only group is this right here. Is their solution. Points in this area, in this triangle area. And remember, it's going to get bigger, right? It's going to get bigger because this line would expand, right? If we had more paper or bigger graph, you would see that that would expand, so that area would be pretty big. And tomorrow I'm going to give you bigger paper so we can actually see a little bit better. So again, see how that area expands. So any point where these two lines intersect, where the blue and the black intersect, is a solution. And just to prove that, I'm going to pick a line here. We're going to pick a point. Let me pick a point that's easy. So let me pick 1 and 4. 1 and 4. So if I pick the point 1 and 4, and I'm substituting for that equation and the first one was y equals greater than 4x minus 3. So I'm going to substitute that here and substitute that here. It should work for both. So let's substitute. So y is 4, greater than negative 2 times 1 plus 3. 4 is greater. Negative 2 times 1 is negative 2, plus 3 is just 1. 4 is greater than 1. Check, so that worked. Let me use 1 and 4 again. Y is 4, greater than 4 times 1 minus 3. 4 is greater. 4 times 1 is 4, minus 3 is 1 is 4 greater than 1. And it's also true. Okay, so again, a point 1, 4, which is inside this overlapping areas, made both inequalities true, and that's what we're looking for, right? So, and if you picked any of these points in this area, infinite number of points, any of these points would make this and this inequality true. Second problem. So the second problem, likewise, there's not much to do. We can go straight to graphing because it's already in the slope-intercept equation format, right? So the first equation, 3 is my intercept. My slope is -5 over 1, right? So I know it's negative, so it's going to be something that goes down. -5 over 1 is -5 down, 1 to the right. 1, 2, 3, 4, 5, 1 to the right. I'm not going to have room. 1, 2, 3, 4, 1, 2, 3, 4, 5, 1 to the right. So, and this is going to be a solid line. Shoot. Let me get a little better. Nope. Okay, so it's a little bit crooked. That's my solid line. So now I gotta choose left side of that line or the right side of the line. So let's pick the point 0, 0. So -5x plus 3. If I use a test point 0, 0 and plug it in, I will get that 0 is greater than 3, and that's not true. So that means that numbers on 0, 0 is to the left of the red line, right, of my line, which I forgot to label again, -5x plus 3, right? So it means that points here don't work, which means we want this side. So we're looking at that side. These points will make that. So if you pick any point on this side, it makes our inequality true. You know, actually, I don't even know why I do arrows. Well, yeah. Next one. So let me remove the arrows and let's just go like this. Okay. So hopefully, right? So any point on this side to the right of the line makes it true. The next one is a y equals greater than -2. So let's find where y equals greater than -2. There is no slope, so your line should be a horizontal line like this. -2 is over here. So this is going to be a dashed line. Okay. And pick 0, 0. So if I pick 0, 0 over here and substitute, here's my x value, my y value. I can only use my y value, so 0 is greater than -2. That is true. That 0 is greater than -2, so we don't want numbers. So 0, 0 is here. So we want numbers that is above the blue line, not below. So I'm going to go like this. So if you look at that, here is your solution area. Right? That's where the blue and the red intersect for me. Right? And if you pick any point in that area, it would make both inequalities true. So if this was a test, I would definitely ask you to pick something. So let me pick a very easy value. I would pick, I don't know, like 2. What is 1 in there? Yeah, 1 and 0. Anything with a 0 is obviously very easy. So 1 and 0. 1 and 0 is in this area. So it should make both inequalities true. Let me just clear this so I can see what it is. So the first inequality, I get y greater than -5x plus 3. If I plug in 1 and 0, remember, this is your x value, this is your y value. So 0 greater than -5 times 1 plus 3. 0 is greater. -5 times 1 is -5, and -5 plus 3 is -2. So yes, it worked for the first inequality. The second equality is y is greater than -2. We can substitute the 0. 0 is greater than -2, and as you can see, this point here, which is in this overlapping area, makes both inequalities true. So, and that's exactly what we want. Let me charge my computer if I find my bag. So that was simple. Like I said, tomorrow we'll do a couple of problems on. I'll print out a bigger sheet, a sheet that maybe has just one coordinate plane on one side, and you can actually you don't have to You have to see it better. Okay, so that was part one. Let me see. So now I think we have a few more things. All right, we got this. So cut, copy, bring it over here. And I think we want to do number 6 on each. Oops. Yikes. So I said number 6. Let me just go like that. So we want to find the nth term. Yeah, right. So let's just start with number 1. So number 1 was number 6, sorry. 8, 11, 14, 17. I take the first difference, 3, 3, 3. I can stop right here. This is a sequence that goes by 3. It's a linear sequence, so it's an n sequence, right? But to be more precise, it's one that goes by 3. So a 3n sequence goes 3, 6, 9, 12, etc. Now, I ask myself, well, how do I adjust my 3n sequence so I actually get 8, 11, 14, 17. My first term on this sequence is an 8. Well, my first term on the 3n sequence is a 3, so I have to do some adjustments, right? So, and obviously, from 3 to 8 is plus 5, from 6 to 11 is plus 5, from 9 to 14 is plus 5, from 12 to 17 is plus 5. So it's a 3n sequence plus 5. So, and if you want to double check, let's pretend n equals 2. If n equals 2, you get 3 times 2 plus 5. 3 times 2 is 6. Plus 5 is 11. Is our second term 11? Yes, it is. So pick another one. 3n plus 5 is my sequence, so let's pick 5. I don't have 5. Let's pick 4. My fourth term should be 17. Let's see if that's true. So 3 times 4 plus 5. 3 times 4 is 12. Plus 5 is 17. So my fourth term is 17, and it matches. Let's do number 6 from the silver group. 6, 21, 46, 81, 126. That is 15 on 25, is it? Yeah, yes, 25. 35, 45. Obviously, they're not the same, so right away I know that this is going to be a quadratic sequence. I just got to figure out if there is a coefficient here. Let's take the second difference. 10, 10, 10. If I have 10, right, half of 10 is 5, so that's going to be my coefficient. This is a 5n sequence, which we're going to n squared, 1n squared is 1, times 5 is 5, 2n squared is 4, times 5 is 20, 9 times 5 is 45, 16 times 5 is something, 16 times 5, 80, and 25 times 5 is 125, right? So that's what a 5n sequence would look like. So let's subtract. If I subtract, I get 1, I get 1 again, and I get 1, I get 1, and I get 1. So they're all the same, right? So you can stop right there. So this is a 5n sequence, and to adjust so I can get the 6, or to adjust so I can get the 20 to 21, and the 45 to 46, and the 80 to 86, I have to do this one. Let's see if it works. So let's pick 4. 5 times 4 squared plus 1. That should give us 81, right? Because that's our fourth term. So 5 times 16 plus 1. 5 times 16 is 80. Plus 1 equals 81. Check 1. Let's check twice. Let's pick 1. Our first term should come out to 6. So when I substitute n with 1, I get 5 times 1 squared plus 1. 5 times 1 squared is 5 plus 1 gets me 6. And there is my first terms. So that's check. 7. No, 6. 9, 23, 45, 75, 113. This is 14. This is 22, I think. I don't know. This is 30. And this should be 38. And no, it's not a linear sequence. So it's quadratic, so it's going to be n squared Let's find out the coefficient. Take the second difference. It's 8, 8, and 8. Take half of 8, it's 4. So there's our sequence. 4 in sequence goes, well, 1 squared times 4 is 4. Nope. Yeah, it's 4. 2 squared is 4. 4 times 4 is 16. 9 times 4 is 36. 16 times 4 is 64. And 5 squared, which is 25 times 4, is 100. Subtract. You get 5. You get, I don't know, 17, 7, 8, 9, 4, 7. You get 9. You get 11, and you get 13. They're not different, so that's fine. Let's take the, what do you call the difference? It's 2, 2, 2, 2, 2, 2, 2. And it's going by 2s, and the only thing that goes by 2s is a 2n sequence. So it's a 2n sequence, right? And a 2n sequence, if n equals 1, it's 2 times 1, which is 2. If n equals 2 is 2 times 2, which is 4. So 6, 8, 10. A 2n sequence goes like that. So far I have 4n squared plus 2n. Now, is the 2n squared enough to get what we want? We want to get to 5, right? Because this is also plus 2 plus 2 plus 2 plus 2, just like this one. So, but we have to make a little adjustment because we want actually 5 to be our first term, 7 to be our second term, whereas with a 2n sequence, the first term is 2. So obviously we have to, and if you can see that everything's adding 3 plus 3 plus 3, 6 to 9 is plus 3, 8 to 11 is plus 3, and 10 to 13 is plus 3. So this is a plus 3. Substitute, let's pick 1. I don't know, first let's see. When n equals 1, I should get 9, so let's see if that's true. I get 4 plus 2 plus 3. 4 plus 2 is 6 plus 3 is 9. So I checked once. Let's check for n equals 2. 4n squared plus 2n plus 3, and let's see if our second term comes out to be 23. 4 times 2 squared plus 2 times 2. I'm replacing the 2 with 3. The n was 2. 2 squared is 4. 4 times 4 is 16. 2 times 2 is 4. Plus 3. 16 plus 4 is 20. 20 plus 3 is 23. And you can tell our second term is 23. Okay? That's that. And then you had this, which is 7 plus 6v plus 7 less or equal to 60. So this is an and problem. Okay, but the first thing I want you to do is get rid of that 7. Yeah, all we want to do is half the absolute value. So minus 7 gets us what we want, 6v plus 7 less or equal to 53. Okay, so now, those of you, when is the absolute value of anything less than 53? Well, the absolute value of 52 works, 51, 50, right? So the absolute value of 53 also works, right? Because that's going to be 53, all the way up to absolute value of negative 53. Anything that's outside these two circles to the right and outside this circle to the left, it's not going to work because the absolute value of 54, 55, 56, 57, 58 don't work. And on this side, the absolute value negative 54, 55. So we're constricted by negative 53 and 53. So anything between these two numbers works. So right away, so if you, that helps. I think it helps. And then you can set your, now you can set your inequality. 6v plus 7, get rid of the absolute values. 53, and on this side, it's going to be less or equal to negative 53. Right? So that's how you set it. So that's my and problem. This is what I mean. And, right? Minus 7, minus 7, minus 7. So I'm going to get negative 60, less or equal to 6v, less or equal to, I don't know, 13 minus 7 is 6, 46. Divide by 6 now. Divide everybody by 6. So I get negative 10, v, sorry. And 46 over 6, it's 7 and 4/6 or 2/3. Okay, so v, our value of v, if I ask you what can I replace v with, could be any value that starts from -10 all the way, shaded all the way to 7 2/3. Okay, so, and that's my answer. Okay, if I replace v with any value between these two numbers, it's going to end up, and I take the absolute value, it's going to be less or equal to 53. Anything outside those two numbers, we are going to have a problem because it's not going to work. Number 4, 6 minus 2a plus 8 less or equal to 24. So again, so the first thing we want to get rid of is the 8, so minus 8, minus 8. So this is 24 minus 8 is 16. We got 4, 6 minus 2a in parentheses in absolute value. Divide both sides by 4. This cross out, and finally I get what I want, which is this, less or equal to 16. Well, less or equal to 4. This is almost the same problem as before. You should think about it. I'll draw my number line. The only time the absolute value of this, it's only going to be less or equal to 4 when it's, you can take the absolute value of 4, that's going to work. 3, 2, 1, 0, -1, -2, -3, -4 works. -5 doesn't work because if I take the absolute value of -5, it's 5, and 5 is not less than 4, so that does not work. So this is our area, this is where we're going to apply. Okay, so we have to be in between these two numbers. So therefore, when I set up my inequality, it's going to be 4 over here and -4 over here. And this is going to be 6 minus 2a. Remove the absolute value sign. Let's do minus 6, minus 6 everywhere. And we get -10, less or equal to -2a, less or equal to -2. Divide by -2, everybody. So -2 and 2 is 5. We're going to reverse that sign, point that way. Cross, cross, and 1. So a has to be greater or equal to, has to be less, has to be a number between 5 and 1. Okay, so now again, you can always do a check, right? So if I were to graph my answer, right, the value of a, my variable, is going to be between 1 and 5, and shade. So my variable a has to be any number between 1 and 5, and then let me pick 3, and I'm going to plug it in here, see if it works. But the absolute value of 6 minus 2a less or equal to 4, if I switch the a for 3, I get absolute value 6 times 2 times 3 less or equal to 4. And 6 minus 2 times 3 is just 0, less or equal to 4, and the absolute value of 0 is just 0, and you can tell that it works. And just likewise, you can also pick a number outside just to see that it doesn't work. Okay. And we had, I think, one more. And I don't know if I said 7 and 9 or 5. Oh boy. I think I said 9 and 10. Yeah. 9 and 10. So I'm going to do 9 and 10. So this is right 9 and 10, which is 0 and 4. And -5 and 0. So want to find x1, y1. I'll call this x2, y2. Subtract. So my slope is my change in y over change in x. So it's y2 minus y1, x2 minus x1. So y2 is 0, y1 is 4, x2 is -5, and x1 is 0. 0 minus 4 is -4, -5 minus 0 is just -5. That's going to be negative divided by negative, so I might as well just write 4/5. So that's my slope. So m equals 4/5. So if I take my equation here, mx plus b, I get y equals 4/5 of x plus b. Now I need to find b. Well, if I need to find b, I have to replace the y and x, right? As of now, I have 1, 2, 3 variables, the y, the x, and b. But if I choose this point 0 and 4, which is I think better than -5 and 0, put it in this equation, I get y, which is 4, equals 4/5 times 0 plus b. Well, that's just 4. This is 4/5 times 0 is just 0, so this goes bye-bye, and I'm left with b. So b equals 4. So my y-intercept is 4. Now I have a value for b, and I have my slope. I can finally write my equation. My equation equals y equals 4/5 of x. This is my slope. And this is my y-intercept. Okay. 10, 0 and 4 again, and -5 and 5. So let's find our slope. x1, y1, x2, y2. We get 5 minus 4, and x2, which is -5, minus x1, which is 0. 5 minus 4 is 1, -5 minus 0 is just -5, so my slope is negative. Okay. My equation of my line. So right now I'm going to replace the m with -1/5. Notice I changed the negative that was on the 5 to the negative that's 2, and I put the negative next -1. Really don't matter. Okay. mx plus b. This is not the equation of the line, right? Because I need to find a value for b. So in order to do that, let's pick either this one or this one. I would pick 0 and 4 because it has a 0. Plug it in, and we can find the value of b. So 4 equals -1/5 times 0 plus b. That's 4. This is going to be 0 again, because -1/5 times 0 is just 0. And then b. So my y-intercept is b. So to finish it up, y equals -1/5 x plus 4. That's the equation of my line. And I think that is it. Why do I feel like that was so little? Alright, that's it.